So basically, part of today we're going to look at roll-up design, but we're also going to look at some of the design tools we use early on in the season to help us kind of lay out a plan without having to do a lot of CAD, and so we can just get used to what we're designing. So the four things we're going to talk about today are our design slide decks that we have, CAD sketches and how we use them to kind of like figure things out and get a better mental picture. The one step up from CAD sketches, which are block robots or Crayola robots, or whatever you want to call them. They're just really quick CAD sketches where you don't have a lot of detail, but you have a full 3D shape. So this helps a lot, especially if you if it's harder for you to visualize things in 3D without actually seeing it. This lets you do that relatively quickly without having to spend a lot of time in CAD. And then the last thing, as we get closer to the end, if we get to it, we'll talk about the design calculators and kind of go through a couple of those. So design slide decks. So these ones you should all be, who a returning student should all be familiar. These are where we document our design reviews every week. But at the beginning of the season, we also use them for documenting ideas. So one of the things we need to do, and we have not yet, is make one for roll up. So we have a slide deck that we can all edit. It also may be useful if you want to have like your own slide deck somewhere where you're able to add ideas and make notes and things. If you don't want to like do it in the public or the one that everyone sees really quickly when you're still trying to like format some ideas and kind of think through things, that's totally fine too. And then you can just copy slides over. But there's also where we hold, like as we go through and do PowerPoint sketches or we do sketches or we make little like PowerPoint sketches with shapes in PowerPoint tool, that's fine too. Like you don't have to have perfect dimensions on everything for like the idea portion of it. A lot of it is just brainstorming and just understanding the problem, because so much of our design process and the important thing that we do is getting a better understanding of the problem so that we can make good choices and then implement those choices. It's really easy to be like, oh, this is the way to do it, and then not have a real complete understanding of the problem and realize, oh, we missed this aspect of it. Yeah, so that's where we want to document a lot of those things and hopefully get everybody onto the same understanding of the problem, so then we can all attack it well and come to a consensus on the right design that we're going to be able to build. The other design slide deck, which is relatively new now. Oh, that's weird. Okay. All right, Zoom. Let me get back to sharing and I'll just share the whole browser. Okay. So this slide deck was the back end of a different slide deck for a little while. But now it's its own. And I guess will be public now that we're doing it in the training video. So I'll link it there too. It covers a lot of design examples that we've had that we just collect over the seasons from a lot of from different parts of robots that we think we could use in generic ways. These ones aren't necessarily game specific. So the slide deck that we'll create for roll up will have a lot of very specific design examples, especially for like different ways that people did hoppers in 2017 or different 2016 intakes, since we're using like the similar game pieces that we've already had in the past games. So there's a lot of information and pictures and videos and things we can pull that'll go in that specific slide that wouldn't be in this, right? These are more kind of more detailed solutions for little things that we can learn about and apply to some of the other things we do. So this is kind of like specific things on ways to build some of the rollers that we've used in the past. I'm not going to go through all of these slides. This is definitely just like a reference thing for people to look through. Different pivots we've used, different pivots other teams have used, intake stuff. Like there's a lot of different things. They're kind of in pretty broad categories because sometimes maybe this thing is not used for an intake and maybe we're using it for something else and we don't even know how well some of those work, right? Maybe it's part of instead of using this for an intake, maybe we're using this as part of our like ball tower or something, right? So we didn't want to like make them too narrow-minded in their use cases. A lot of the point of this is to get ideas that we can then apply to other parts of a robot and things where they may not have been originally used. Okay, so yeah, so that's all just roller stuff. There's some turret things in there, some wheel things. A bunch of the others like generic mounting things. So this was like, I'm pretty sure this is a picture of a 118 catted part from their 2017 robot, I believe. Oh yeah, it says right there. So a lot of this is just times where if we want to document, if we see cool things when we're looking through CAD, or if you see something in a video or a chief post or something that you don't want to forget, or you think the whole team can learn from, this is that same type of ideas. Yeah, so this is like a 3310 part. There are a lot of different robots and things that could do it. This was just somebody had a post on Chief about it, and it's useful information.
What do you mean by like a 3310 part? Is that
That's their FRC team. That's the team number.
That's what
Yep, most random numbers are team numbers. Yeah, so different ways to mount things, all sorts of different little tiny, potentially cool, useful stuff for you to learn, or be able to use in different parts of our problem solving. So it's also useful as we're going through robots to go back into this and add things where we can. There's a whole section at the end of just like miscellaneous. So if you're not sure where to put it, just make a slide in there and it's fine. Lots of little breaks, latch releases, all kinds of things like that. There's a single drivetrain image currently. Probably should get some more of those at some point. A bunch of stuff on climbers and telescoping things. There's a single bumper image, which we probably need to expand. Some controls and pneumatic stuff for different ways to mount and label and mount sensors. That probably gets to move to new electrical at some point. Okay. Yeah, some program ideas, and then the last bit are just some random kind of miscellaneous things that may be useful in the future. Yeah, so those are two useful places to be looking for ideas and things, and we need to make the roll-up slide deck. So that's one of the things we'll do today. And then we'll also talk about and look at more of our sketching. So anyone who came in a little bit early, Felipe was walking through doing one of the, basically the same thing we would do, the exact idea that we're talking about here is using a 2D sketch to lay out some problem. So we were trying to figure out how we would do roll-up intakes and how you might be able to combine two different intakes. And we did it really fast. It took, 10 minutes, whatever that was, to talk through a sketch for a dual ball intake setup. This was last year when we were understanding the game before we were understanding robots, right? So the robot is depicted as as just a box here. This part of the slideshow, that seems, interesting. Let's try that again. All right, there we go. So yeah, so the robot is just depicted as a box. So there's nothing special to this at all, right? So this was just a very simple CAD sketch. It has a ground. It had the goal from last year. So this is the exterior, like the big hexagon part of the goal, and this was the inner goal. So we have those set up. So then we could just kind of see what the ball path, like kind of angle would look like and what it would to be able to get to that inner goal. So this was a lot of just figuring out, did we want to be tall, short, where did we want to shoot from? We could just do that with the sketch. So this is the side view. This is the top down view. So you can see how weird it is from different angles. So how far away could we be left or right and still make the inner goal or make it into the goal? So those types of things with the field are really useful to get sketching like that. This was a little bit further into the season. I don't think it was that far. This was on the blog. But this is basically just a layout very similar to what Felipe was doing a second ago, and that we're going to do here in a second, of like the double intake. This was the full robot path. So this was figuring out, okay, we had an intake. We'll have some way to bring balls up. Ball tower, how do they stack in here? How much room do we have for a shooter? This line is like the max height of a robot. But it's literally just like squares, circles, arcs, nothing too crazy, and then a lot of dimensions to try to lay stuff out and get things fixed into place a little bit as much as we can. I think that box is the color wheel or like the control panel. I'm almost certain that's what that is, which is really awkward because it never ended up there and wasn't even on the robot for our only event. Okay, and then I'm not going to go into the calculators, but we will talk about what a block robot is. So this is basically what last year's block robot was. So at that point, we had most of a drivetrain done, so I was able to use that as the base of it. And then all of this, you can tell, like, does not take long to CAD, right? Like I threw some wheels in, attached them to a sketch, made something for the buddy forks that is literally just like a giant L, right? It's like two rectangles. Same with like this elevator, it's just some rectangles. Like none of this has to be hard or complicated in any way. And that lets us kind of see closer to what everything will look like in 3D, especially if it's harder for people to visualize just the 2D sketches, right? There's not much difference between this and this thing, eventually if it goes back there, and this thing. But it's definitely easier for people to understand the 3D thing some of the time. So I try to get this done, especially for our design reviews when we're showing it to everybody, because it's a lot easier for people to understand this than it is to explain every part of the sketch and have them kind of like build out what the robot's going to look like just from the sketch. Okay, so we'll talk about design calculators later. Let's get back into talking about roll up. So what do we need? So we need somebody want to make a document? I can make the document. That's fine. What am I looking for? So we're going to make a Google Drive doc for this season, a Google slide that we can start taking notes on. Google Drive's being slow. Okay. Okay, now we're getting somewhere. Okay, so now we have a roll-up folder. We'll make a new slide document for it. Roll up design slides. The easiest way to make stuff be the Spectrum presentation is to import theme and pull from any of the other Spectrum presentations. All the training ones have it correct. And you do select and you have a nice Spectrum theme. Hit import. So then you don't have to do anything to get like triangle bullet points and things. Okay, so in here is where we would have ideas from other robots, notes from Kickoff if we had any. I don't think we had too many. There's some things that should get linked into there, like the calculator that we had on Kickoff, the whole slide deck probably. And like the question sheets would get in here too if we were doing this in a real season. So we probably should get that in there as well. Pictures of Felipe's, the CAD that we were working on with Felipe would go into there. All of that would happen that way.
I do not have SolidWorks, but I do have Tinkercad. Could I use Tinkercad
You can
if
do
I
it. If you want to draw something up in Tinkercad, do it in whatever tool you want at this point. Yeah, we're not, for this stuff, we're just figuring out ideas and brainstorming.
Okay. So just anything that
For this stage, yeah, it doesn't matter. Like I said, people can draw them in PowerPoint. They can draw them in Google Slides, right? If you want to draw out robots with different shapes and things, you can communicate your ideas visually in a lot of different ways at this stage. And it's totally fine. It's whatever people are comfortable with. Okay, Felipe, you want to get a screenshot of your drawing and get it in here?
Yeah, I'm doing it right now.
We can get some of the other ones in there too. Pull that. That's not
There's so many dimensions that I did not do.
on.
It's like everything can move.
Right, but yeah,
sometimes.
when you're just starting out, it's fine when things can move. A lot of times I'll go in and add those dimensions later. Just figuring out where some of that stuff is. We have a manual. Sure. It's being weird. It's like it has hyphens instead of triangles. There we go. There's everything being weird. I don't know what's happening. It's being really annoying. Okay, let's try that again. All right.
Oh, could you name the presentation?
Oh,
search it out.
Sorry. There it goes. Yeah, if you as soon as you name it on like the title site, if you just click up there, it copies the name, and I just hadn't clicked up there. Let's see.
What does roll up mean?
Okay, yeah. So if you missed Tuesday, one, you've been giving very good feedback for missing Tuesday and not knowing what the game is. Feel free to look through the manual. There's a one sheet too that will link in a second. Tuesday is when we went over what the game we're using as our test game.
I think there's a recording of that.
There is a recording as well. Yeah, it's on YouTube.
Watch like the first like 20 or 30 minutes because it's pretty informative about what we're going to be doing.
Okay. Then I guess I should watch that.
It is, yeah, that is definitely helpful to what we're doing. The one sheet works somewhere in here too. Let's see. Kickoff notes in there. Okay. All right, really useful. Yeah, so we have that 2-ball intake sketch. And so ideally when you have sketches, you would like add a couple notes like intakes both balls from one side and like point out some of like the key ideas like the bumper gap or whatever for launcher, but filled for intake, that type of thing. So a lot of what else we would do in here right at the beginning is we would go through and look at examples from past years. So it's a lot of what we would do, especially if a game, if we were ever given like another, the same game piece again in some year, we would absolutely just go in and look at robots from those years, right? So there are a lot of 2013, 2017 behind the bumpers videos. So behind the bumper videos are great because you can see a lot of details in how the robots worked. So we can see different teams and how their like sorting system or whatever worked. I don't remember. I'm trying to think which ones are super useful here. A bunch of these are not 2017, which is weird. I'm pretty sure he did some in 2017. I don't know why it's not searching. giving back useful results. Maybe they didn't have very many 2017 ones. Huh. We could figure that out in another way.
Hey, fun fans, Nick Jr. here from the Intimidation.
Pause. In general, if you just want to learn more about robots, behind the bumpers are really useful for that. There are a ton of them, and they have the teams going through and describing everything their robot does, which is great. It seems like maybe they
Has
didn't.
Spectrum ever done a behind the bumpers?
I'm not sure actually. I don't remember. I think we filmed one. I don't know if it ever got uploaded, but it might not have been with them. It might have been with somebody else. Like people come around and interview you and things. Fun is normally at a lot more North events, but they are at Champ sometimes. We do our own. We have other videos and things that you can watch on our website to learn about our robots, though. Yeah, it doesn't seem like they have any in the playlist from 17. Maybe they had not done it for a while and then picked it back up in 18. Interesting. Okay, well, either way, you can look at some of the reveal videos are useful. Some of the other, you can also look at CAD. So there's a ton of places to get ideas. We don't need that right now. Okay, yeah, so we have some stuff getting filled out about this idea. Some of the things we know that we haven't laid out. So like we would lay out things like subsystems in here, so everyone has an idea of kind of what different things we'd be working on. So we know we have to make a drivetrain. What are the other subsystems that we had talked about for this robot?
Some sort of big ball launcher.
Or share
and small
intake,
ball.
some sort of
Yeah, big ball, launcher, intake, whatever. Small ball, same thing.
Ball storage.
That is
Climber.
reasonable, yeah. Climber, and then that's mostly it, right? There's some versions of these things all have to interact really closely. Those two can be slightly separate. Is there anything else in this game that we have to do? I don't think so.
Think so.
Right? Bumpers fall into this place. And there's some amount of controls plus programming, all of that, right? Okay, so we've had discussions about some of these things before already. I'm trying to think, what are some of the like questions and things we know we're gonna have to decide inside of some of these subsystems?
The speed bump for the drivetrain.
Yes, speed bump's gonna be important. And ramp, right? Speed bump, ramp, both of those are important.
Dimensions because of the small ball height limit. To leave more space maybe at the bottom.
Oh, I see what you're saying. Yeah, like volume. Yeah, okay, I got you. Okay. Climber, we have to figure out like there's different ways to get to, I think we discussed this on Tuesday. There's different ways to get full points, right? So there's some sort of use the high bar or not use the high bar to do it. Because in theory, there's some way to do it without using the high bar, but we don't know how easy that is. Use the or not. I don't know. Did we actually decide whether we were? I think we decided because we're virtual for sure, we're going to figure out a way to design the climber and actually climb, but whether we would do it in real life and only High Park is a different decision, right?
Yeah.
Is that the conversation
Yeah,
we had?
definitely. Yeah.
Okay, so yeah, so how to climb. Okay, and then these ones are where it gets a lot complicated in the launchers, right? It's the same side or different question. And then also the meta same side or different question with both types of balls.
Mhm.
Oh, what's the other? At some point we discussed the small ball thing about whether it was like single stream or double stream, right?
Yeah, we did.
Yeah.
So if we're going for a top goal, then we have to.
Yeah, a lot of this we should have wrote down on Tuesday probably, and we would have during a real kickoff, but it's fine to come back to it as long as we don't horribly forget something. Top goal, upper ring, we can be.
Even getting in the inner ring with the double stream would be kind of.
Well, yeah, but but you have more options because you can like be missing some, right? And you still get outer ring points. Where if you like double
Okay.
stream fired at the top goal, one of your entire streams is getting no points, right?
Yeah.
If you were doing them simultaneously.
Mhm.
Most likely getting no points because we have no way to test whether weird bounces do happen and they somehow like end up in the outer ring. I don't know how that would, but we did not intend for that in our design part of the game. We did not intend for that to be a thing, so I'm going to go ahead and say it's not a thing. But it wouldn't be impossible if there was some sort of bounce that ended up happening, but that seems unlikely. Launchers probably right. Okay. What do we want to? Oh, there's another drivetrain thing at some point, right? There's also like, there's the swerve question mark decision. Which is a big decision. Okay, so I guess part of what do we actually want to do today? So I think the ball challenge is definitely the most crucial to figuring out stuff on the robot, right? Because without knowing roughly how you want to interact with balls, I don't think you can know much anything else about the robot, right? Because Climber, there's probably a lot of options to package around ball intakes and launchers. Drivetrain can be different things based on kind of what the needs of the ball intake and launcher are, I imagine. So we're probably doing more stuff with this thing. So part of it is also we would definitely, in the real season, we would be prototyping, right? Which we're not doing. So this question, is there a design way to make this decision? Or is it just a decision we make and assume we would actually make it with prototyping?
This is just a very weird idea that could work for simulation. I know that Roblox Studio has it's a big physics simulator, so you could put some objects in it and you could see how the whole ball thing plays out.
So you can do some stuff in simulation, but it's not for what we're doing and for the way FRC works. It's not worth, because like part of what we're trying to do is model our real process, and since we would use the real thing in real life, we can make some assumptions without having to like learn a new thing, because that skill doesn't help us in the real season very often. Like if it's something you want to play with, feel free. But it's not something that I'm going to go through and be like put a ton of effort in, because that's not what we're trying to get out of this project.
And yeah, because because you would usually just prototype in real life, and that's better because the real variables can work and you don't have glitchiness and stuff.
That is correct. Screen share is not the part of the screen I want to do. Yeah, so this is the field, which we went over on Tuesday. So yeah, so you're not sure, Felipe, if we would be able to do 2 streams into the inner, right? That was your
Yeah.
current thought. I don't actually know how big the inner goal is. I don't remember. And it no longer wants to tell me how big the inner goal is. There it goes. It's 14 inches, right? So it's a reasonably sized goal. What could we compare it to? Oh, I know what we compare it to, but I think it's gonna be way under. We could compare it to the 2017 goal. But I don't actually know how big that is, but it's almost certainly way smaller, which is a little scary. I don't know if I have a 2017 field somewhere. Because we know 2 stream of balls did go into this one because, yeah, so they had, no, it's not that much. It was 15 at the
Yeah.
straight tube. It was a little bit bigger at the very top, right? That's the vision target. That's not even the boiler itself. So it was, it was 19, no, it was 21.
21 and a half, yeah.
Ooh, we took a third out of it. I feel like maybe that was something we should have checked. Interesting. Interesting.
Well, hold on.
So yeah, I think Felipe, you make a pretty good point. Maybe dual streaming into this goal is not possible. So because if you can't dual stream into this goal, then I don't know if it becomes worth it, right? Because you did your like version of the scoring thing was counting on quite a few balls going into the inner goal, right?
Yeah. I can check how many.
Like I'm just vaguely remember what percentages you had written down.
Yeah. It was 50
Yeah.
in the inner, then 40 in the outer.
And like 10
Wait,
missing, is that what it was?
Yeah, 10 missing.
Okay. Yeah, and that's like 50 ball cycles, which is really big cycles. But I guess you were doing a whole extra cycle, right? You were doing
Yeah, I was doing
6
6.
cycles. Okay, that was a lot of cycles. But even if you knock it down to like 4, you can still like do a lot of points.
What do you mean by cycle?
Number of times you basically like line up to shoot, right? A cycle is the process of like going, like the end of the time you shot before, where you're like your robot's basically empty. You go out and you intake all the balls, and you get ready to shoot again. You line up, you fire all your balls. Your robot's empty again, right? So it's like the pattern. It's like the step and repeat of the entire match, where you do this one thing kind of over and over again. But it's multiple things, but you do them in order, right? Your robot can only hold so many balls. So you intake them all, go and shoot them.
Yeah, it's going to go around and collect 40 balls and then just line up and rapid fire shoot all 40 and then go do that again.
Yeah, so in that, if you were doing only small balls, there's maybe some version where you're collecting 40 balls and then collecting 2 big balls, and you line up and shoot all 40 small balls and the 2 big balls at the same time if you were doing both game pieces.
Okay.
Yeah, so you're just trying to figure out what's the thing you would be practicing, what's the most efficient way to score. And that's roughly what we consider a cycle, is that kind of repetitive thing. And then you can figure out how long it takes you to do it and how many matches you could do it in.
Let's see.
So that's what this sheet does for us. We can tell it like how many seconds we have 4 cycles. So this was 120, which leaves us a little bit of time to climb, where it's assuming we're not cycling. And it tells us it would take us 30 seconds per cycle to do that, which is a pretty decent amount of time. Like that's a relatively slow cycle. You could probably go a little faster if all you're doing is balls. Because then the next thing at some point is to start figuring out, okay, how long do we actually think a cycle takes? Which is like, how long does you have to drive around? How much intaking do you have to do? How long does it take to line up? How long does it take to shoot? And those guesses, or educated guesses, estimates, are tricky to do a lot of the time.
Are the big balls and small balls going through the same shooter?
And in this plan, no, but there may be some version where they could.
So is that,
I don't know how that would work, but
does a spreadsheet account for the robot? Like, are the shooters, are they angled toward the same direction, or
the spreadsheet doesn't. The spreadsheet doesn't know any of that, right? Like that's not. It's not
Okay.
intent. Like the spreadsheet doesn't know anything. This is all this is doing is like you have to add in time for whatever you want to add in time for and everything else, right? This is just doing some percentage math, so you don't have to. Right. This is not a complicated spreadsheet at all. But like, there's no reason you couldn't design it to where even if they're not the same shooter, it could be the same aiming spot, right? Like one could be coming out below, one could be coming out above. Like there's ways to have different mechanisms do the firing and them still going in roughly a straight line.
Oh yeah, you could have like maybe intakes from different locations, and but they both go toward the same shooter direction.
In this version, what we were discussing, the small balls would come out from underneath when fired, and the big balls would come out the same intake path, so they'd end up being they'd be in the same straight line, and the same side of the robot and everything. Which makes things a little bit easier on weight because everything's kind of built into the same spot, but it makes things, it's a little complex because everything's built into the same spot. Okay, so any other thoughts or comments on this question? Because I think without that question being answered, it's a little trickier too. It's also a little tricky to do. So single stream shooting in general is just harder from 2017, and like especially doing it quickly. Because we can see some of the good 2017 robots. Does Citrus have one of theirs? We can look at like poof stuff too, but oh, they have a whole season recap. That's fun. There's some different prototypes. There's a couple different shooters. So that's 1678. They were double wheel. That's Madtown. They were like single, but they were able to do what's called a die rotor. It's actually like, it was inspired based on like a paintball hopper, the way it works, but it's feeding up, which would be way trickier to do when we're feeding down and out. But these double ones are a little bit, the way they were going, it's a little bit easier. Dancing out of them. Recap video is very little robot in it. It's like, okay, there we go. That was a decent one. Yeah, so basically the way they do it is like these side wings are basically powered in bringing the balls down to the center, and then this bottom bed is just bringing the balls towards their shooter, which has wheel or rollers that bring it up towards the launcher wheels. So nothing too complicated there. Yeah, and they didn't have an over the bumper intake. Their intake just came in the split entirely for that season, so that gets a little harder for what we're trying to do. 254 the same season also was dual, I believe, off the top of my head. Maybe if I can figure out where to they like not run their auto. That's weird. Oh, there you go. So they're just like a big hopper. You can see a full stream of balls coming out. So instead, that's also what we have to deal with. We're rolling them across the ground instead. But you can see how it intakes them. This game has no way to do hoppers. They have to intake all from the floor and roll up. Still working out there. Two trains has 2 more gears cleared to that blue line finish. Some more to be red. Need to get 5 more. From here. Throwing up more fuel into 2. But yeah, you can see how much they missed though too, right? Like it was not. This was a very hard shooting test. It was very hard to be accurate when you're shooting that many balls that quickly. And still climbing as he process that fuel in the course of action. We have just over 1 man. Okay. What do no wrong one.
So why is double stream easier than single stream?
Why is double stream easier? Okay, so that was the thing. Thank you. That was what I was trying to get to. You don't have to force the balls into a single row, right? So there's less opportunity for them to jam because you just have to get them into a row of 2. The other thing you can do is some like half version. So our shooter in our eventual shooter in 2017 was, instead of being, it wasn't double wide, it was actually 1.5 wide, which was reasonable. That would probably make it pretty hard to score into the top ring because you don't have an actual like center spot, but you end up launching balls in like almost like a zigzag pattern, and they could probably fit in the inner goal a little bit easier, and you don't have to do nearly as much like sorting. Where's like, I'm trying to think, where's a team that did it well? What's why am I blanking on a number? Apex had a cool, so to be able to do single stream for Apex, they had to do this thing inside their tower to be able to get the balls to do what they kind of wanted. It's right here. So you can see they bring in balls right here, right? And then they have a wheel here that kicks this ball kind of like, if there's a ball on this side, it kicks straight up. Then there's another wheel here that if there's a ball over here, it like comes in around it and comes in behind it. Because if you try to just like only bring up one ball, it's very easy for 2 balls to get in front of it and just not go anywhere and just jam. It's possible we could solve that with something else, right? Like we know the V funnel works relatively well because we did it in 2020, and I don't remember too many people trying it here. It's a little bit trickier with this many balls, but maybe. But you can kind of see it. I think that's the only place where they really show the back, but you can see the balls every once in a while come up the wrong side. Maybe if we slow it down. Super slow. So yeah, like there's like 2 balls and then they get moved over to the center, like those 2 right there, right? Yeah. If you don't do something like that, it's pretty easy for it to jam, but maybe there's a way to do it without that. But partly that's hard because, again, we can't really prototype right now, which is less fun. So what is your... What was I trying to ask? So yeah, so if they were the same, like if there wasn't a difficulty with jamming and we assume we can solve the jamming issue, is single stream better? Because no matter what, it's gonna be slower, right? Because it's gonna be slower to get the balls out of the robot, right?
But if we end up missing like way more with a double, then
right, then it doesn't. Yeah, then it's not worth it either. Because yeah, because if you can focus on improvement, because even if you intake fewer balls, but you can get your accuracy higher, you're going to come out with more points, right?
Let's find out. Spreadsheet time.
Yeah, I mean that at some point that almost has to be true, right? It depends on how much more accurate you have to be. But yeah, so if we assume with the double we're down at like we're missing 30 and we're making like 40 and 30 maybe, something like that. So that's like 160, but if we do single and we're shooting, I don't know, 25, no, let's just cut it in half. Let's say it's the exact same amount, right? But then we're able to make a lot more. What is that? That's like 50. We could make, I guess you'd have to make your accuracy even higher to do that.
Oh, geez, it's still not less.
Yeah, it's still not there, right?
But cutting it in half from 40 to 20 is also a lot. Like, we'd be more around like at least 25, if not like 30.
Well, but you're still like, I mean, there's only so much time you can get the balls to be coming out, right? Like maybe you were able to speed up your single stream a little bit, but I don't know how much faster you could really do it compared to the double stream. So like it's going to take longer to do it, right? Like maybe you can store that many, it just takes slightly longer to shoot them, right?
Yeah, I got you.
But that's probably fine. And that's also like we didn't change too much of down here, because if we drop this a little bit, that immediately jumps our points a little bit higher. Or is there some play where this thing does end up being better, right? Because as soon as you can shoot, because this is double points, right? This, or 4x the outer and double the inner, at some point this becomes the better option, right? Like pretty quickly, because if you can hit 50%, you're already above. Does that make sense?
Yeah, and if we're doing single stream, that becomes a very better option.
And this gives us a potential to be able to shoot this if we single stream. If you don't single stream, you basically are almost never hitting the top ring, right?
Yeah.
Okay. So we design for single or something close to single, right? I think that's reasonable for now. Without being able to prototype, I don't have another way to really determine that too much. But I think the numbers say, yeah, that makes some sense, because you may be able to eventually make way more points by doing it single. And that's probably a lot of times what you're trying to do is maximize points per cycle is what you're trying to maximize. And by far the most points per cycle would be able to do the top ring if you could do it. Okay. So knowing that helps a little bit, because that also means our bumper gap could be really tiny.
Oh,
right?
yeah.
Like only a 5-inch ball has to exit.
Yeah.
So that's less bad.
I guess you could also maybe have like a more, with double stream, you could have, since you have a separate outtake, you could have a more powerful motor that's calibrated more, that is meant more for those large balls than the small balls or something.
Those are separate in either. Those aren't tied together with double or single. Those aren't related. You can always have a second output. You can always have a different motor doing the launching if you want. Like there's designs that can meet both those requirements.
Well, no, what I mean is there's a separate there's one motor for large balls, there's one motor for small balls.
Correct. That happens either way. That's not required. Like this single stream, double stream isn't small or big. This is 2 rows of small balls exiting or a single row of small balls exiting.
Oh, okay. Then I guess I
Um,
would go with the 2 rows of small balls exiting. You have more balls going out.
Yes, but the entire discussion we just had led to the reasons why single makes more sense for this specific game, because you can get your accuracy more, which is more important.
Yeah, I guess that is true.
Like again, there's arguments for the other that make sense. Like if you'd asked me when we were designing the game, I'd be like, oh, it's probably double stream. It'll be fine. But then when we go look at dimensions and we do things and we see that the score makes sense to, like, if you can eventually get top ring, you can definitely make your score go higher, which is valuable.
Okay.
So
Definitely
that is what and part of it is because we can't prototype, we don't know that if we could ever hit top ring right. It's very hard to judge that difficulty based on just the dimensions at the moment, basically. Okay, so if we know single stream, that's a decision we don't have to deal with. If we know, what are the other issues? Are there any? I'm trying to think, what are the advantages of having things on the opposite sides, right? So like the biggest advantage is having your big ball launcher and small ball launcher on the same side and come out the same path, ideally, so you're not having to re-aim every cycle, right?
Yeah, that makes sense.
That makes sense. That's what we were already talking about earlier. So assuming
but
that's true.
if they're going out of the same place, then how will we get these small balls to be accurate? Because you have to, like, it has to leave enough space for the big ball. So how do you kind of ensure that the small ball is kind of going out at the exact like position and place that you want it to?
I don't understand the question.
So if they're coming out of the same shooter,
they're not coming out of the same shooter. They're coming out of the same direction.
Same path. I assume same shooter. My bad.
No, same exit. Like, so once they're not touching the robot anymore, then they're on the same path.
Yeah. Okay. Oh, I see.
Interesting problem. Okay, so then how do we solve? Because what's the next step? So we have to solve. The sketch is roughly part of that. There's some things about like how do we figure out how accurate we have to be with either ball, right? Big ball accuracy is less important based on the math, right? Well, big ball inner is quite a lot of points, right? You literally get double points for doing it. Interesting, but it should be relatively easier to do as well compared to small ball in the top ring.
Yeah.
We think.
Do we want to talk about like priority big ball versus small ball?
Actually, maybe it's not, because so small balls are 5 inches. You have a 10-inch ring to shoot it into. Big balls are 10 inches. You only have a 14-inch ring to shoot it into. The inner big ball might be harder. But you get some amount of like, you can miss a little bit and still make it. That'd be interesting. Without prototyping, again, it's pretty tricky to know. Priority big ball, small ball. Sure. What did you want to mention?
I was thinking like, how do I put this into words? I guess like, do we constantly go for both when we're playing?
Ooh.
Or do we like go for a cycle of small balls, but if there happen to be big balls, we pick them up?
My assumption was we'd have our human players throwing the big balls back near our goal anyway.
That's what I was thinking.
So we can just pick it up when we're there. Okay.
Yeah, so like your ground load is for small balls, and then on your path back to the goal, you figure out where the big balls are, probably somewhere near your goal, hopefully. You intake them both, you spit them back out once you're aimed, and then you start shooting all your small balls.
That makes sense.
That was my thought. So yeah, so if there wasn't a big ball there, you would just do your small ball cycle probably, if there weren't big balls in your path.
Yeah, because I think small balls are more points. in the long run. Right.
Yes.
So if it's not like convenient, we shouldn't go searching for big balls.
That is most likely true, especially in an actual match where the likelihood of having partners who are who are doing all the big ball stuff is high. That's very reasonable, right? Like, because big balls are easier in terms of like just getting a single big ball to get you points is easier. I would imagine a lot more teams will do big balls. Oh, interesting. Okay. Oh wait, so now for single stream, is this all of this just a Spindexer again on the inside?
uh,
Oh, they do have behind the bumpers. They just don't have the year on these ones. That's weird. Okay.
We want to give a
Oh no, this is 2020. This is a different robot. Okay. But also a Spindexer. That's interesting. But their reveal shows roughly what we're talking about when we say Spindexer. It's basically a spinning sorting system. Oh, we're still on super slow
still
mo.
slow, yeah.
I was like, what is this video? Because roughly, we would just want, instead of having the wheel up here shooting it out, we would want a wheel somewhere over here pulling it out, right?
Yeah.
It's a little weird when it's not at the corner because you're not like adding the ball's velocity, right? The ball's going sideways and you're taking it straight out, so it has a weird want to go away from where you're trying to pull it, if that makes sense.
Yeah.
Because here, when you're pulling it, since it's spinning this way, it wants to go that way, and you're kind of taking it with its motion, with its angular motion, with the the direction of its angular motion. This one would be opposite, or I mean perpendicular, sorry. So it would want to be going sideways, but you were trying to take the ball this way. Which probably isn't too bad. Like, there's probably a way to do that. Well, that doesn't seem so hard.
Yeah. Just having a Spindexer.
That doesn't seem so hard at all if it's just Spindexer.
But I think the bigger question is, where do big balls go now?
Above everything, just like normal.
But then, like, the launcher thingy.
What do you mean?
Or, like, I guess, how are you planning on launching both the big balls and the small balls? Because, like,
In the same. Like, no, so like the big ball launcher is literally like we use the big ball's intake as the launcher.
Okay, yeah, that's where I was confused. Okay,
Yeah.
I got
you just like basically you just store the two big balls in like a tube, and you have like some roller that holds it away, and then you spin the intake up the backwards and fire them out.
All right. Okay,
forward.
I got you.
That doesn't seem so bad.
Yeah.
That seems not terrible at all.
And the small balls will be on a Spindexer.
That was the idea, because you have to somehow get them to single stream, and that is one of the easiest ways to single stream something if you have the space. What would you have to do? Interesting. Okay, so yeah, let's pull SolidWorks up real fast. So rough, like, sketching. Oh, SolidWorks 2020 is interesting. Okay. I don't have a bunch of defaults saved in 20 yet, so it like asks for things every time I do new. Okay, so what are we trying to look at? So we'd have, so Felipe's sketch on the intakes makes sense. The kind of top-down view. Oh, that's another thing. So if you want to start doing stuff even faster, we can go to options. We can search for, where is it? It's in Sketch, I think. So in Sketch, in options, there's a enable on-screen numeric input. Like it seems like a weird name for it. But the super useful thing here is that once that's checked and those two boxes are checked, when you go to make a rectangle, now instead of just like dragging it and then having a smart dimension, it gives you the boxes to type into. So we can tell our robot is 32 by 32 and it does it immediately for us and gives us a 32-inch square. So we can be a lot faster with that than having to smart dimension every time. I also don't have my normal mouse gestures set up, which, oh, that's not in options, that's in customize. There's two different things in SolidWorks. There's options and customize, and they're slightly different.
I think customize is also in options.
There's like a button for it somewhere. Interesting.
Yeah, if you scroll down far enough.
My normal go-to is the biggest one that I use the most is making sure I have smart dimension and measure on my quick options. There's keyboard shortcuts for them too that you can program, but so much of the time I'm CADing, I just have the mouse anyway that it's easier for me to do that way. So I'll normally do measure everywhere that isn't everywhere that's an assembly or a part, and then smart dimension in here and here. So then anytime I right click and drag left, I can smart dimension immediately too. So if I didn't do it while typing, I could do it the other way. We can put a small ball in, so we can do like 5 inches. We know how big a small ball is now. And then we can figure out, what are you doing? Okay, we can figure out what like the Spindexer would look like, right? So it'd probably end up being somewhere on the back half of the robot somehow. Oh, that's interesting. So if we had a traditional drivetrain, we would need to have a gearbox and wheels somewhere in here, right? And the Spindexer would have to be above all that. I guess you might be able to get the gearbox back in the back corner and send chain up to each wheel instead, or the front corners. There's probably a version of that that's okay. So yeah, so that probably doesn't set our drivetrain too much. There's ways to figure that out. You just may end up having to be slightly like wider. Wait, it can't be a 32-inch square. It's 100. What's the frame perimeter is 120, right? Is that correct? I think that's correct.
It's a good question.
Yes.
And
Yeah,
then
let me check.
I'm pretty sure that's right. So then if we had a square robot, you could only be 30 inches, right? Because 30 times 4 is 120.
Yeah.
Oh, that's how math works. Okay.
Mhm.
Okay. So then control click. Yeah. So like sometimes when you're trying to define other things, if you click a point, you can like hover over. You can normally get it to give you the midpoint. Oh, it gave me the line, so I didn't even do it right anyway when I was trying to tell you. So you can click to get it the midpoint, and then that point, and we can tell those to be vertical, which will force that. It'll force this circle not to be left or right, because we assume building this that our Spindexer would be symmetric. Like Like the midline of it would be the middle. There'd be something up here for some type of like wheeled launcher, right? That would launch
Do we
the
want it
balls
to be symmetric?
out. Do we want it to be symmetric?
Because if we like push to the side, right, like, and we put the shooter on the farthest, can I draw? How do I do that?
You should be able to annotate. Oh, are you talking about being able to get the shooter coming off like one of these corners?
Yeah.
Yes, but then like what happens to your drivetrain? Like how do you like one side of your robot like doesn't have room for a drivetrain?
Oh, this is where we get really weird. And put
That's
the
where you get real
gearbox
weird, right? You
above the spin dexter.
right, or like swerve in each corner, right? That's closer, and then you could move it. Making unsymmetrical robot scares me so much. Like, I just like there's valid reasons to it, right? Like, if we were actually building a new infinite recharge robot, the shooter probably wouldn't be on the center line. I think there's reason for it to be on the left, but also they look so weird when and like there's just something like it's so much trickier to build too because like so many things need different parts, right? You just don't have the mirror. It's like there's different lengths of so many things, and like the part count goes up once you stop being symmetric. Like it gets very odd once you break left-right symmetry, like fully break left-right symmetry.
At that point, we just make like a bunch of different reference planes so we can still do weird mirror things, right? If we just like, never mind, it's okay.
I don't know what I'm doing here. It says it's vertical. That's weird. I don't know why it doesn't look right. Okay, this would be, because this one isn't vertical. So this would be like the center ball. And it would somehow get sucked out and run under a wheel, which a wheel from the top looks like a rectangle, right? Like, yeah. So that's roughly like a 3-inch diameter wheel, 4 inches wide, because you would model it from the top as a rectangle. This whole big disc would be spinning somehow. We definitely have to figure out how much room this can take compared to what our drivetrain would need, and then how many balls we could fit into that and how that would work, right? Do we like, do we funnel up the top to be able to do it? And then how do you bring in balls that are coming out underneath itself? That's a very odd thing to do as well, right?
What do you mean underneath this?
Because like in your
What do you mean coming
sketch,
up?
oh, the other way, sorry. It's like they're coming up this way and then all the balls have to somehow get stored and kind of get pushed back, which is kind of hard before they can get relaunched this way, right?
Oh, yeah.
Because normally you bring up balls, they come in, and then they go out the other side, right?
Yeah.
And we're kind of doing the reverse. Because like that's so yeah. So 1986's version is there. 148's 2020 version. Is there a video of that? I don't actually know. I think the only video is like our stuff, right? Like Greg put up some stuff too. Some other people did, but there's a video from Plano. But it's hard to actually tell what it's doing. There's no like good video of it running. Interesting. We have photos, I know, because I took some at Plano. So you have some idea of what it's doing. Pretty sure I took pictures of its Spindexer. Oh yeah, there we go. So this is this polycarb bit is what's spinning, right? And then these two Omni wheels are what bring the ball up into their launcher. Oh, so this version would be really hard because you wouldn't be able to like take a ball out the side because it has a lip going all the way around it. Titaniums would be easier because you have a stationary wall and a Spindexer spinning inside of it, right? Because you couldn't do it with a rotating wall. That would be very hard. Unless you took it up over the rotating wall and back out, but that seems difficult too. Or I guess you could take it like under the rotating wall. That seems like a lot. But yeah, that's the basic idea of how theirs work. This whole thing spun. This went up. That's the turrets on top of that, which is this big wheel right now that's going to launch the ball out, right? So that whole polycarb thing spun around. And then yeah, they brought balls up to be able to load in the top of it, which is similar to what we want to do right now anyway, right? We want to have some sort of plate out that allows balls to come in and over the launching mechanism that would be in that same place. Why do I keep going to the backwards one? Okay. I think that's reasonable. Sorting, whatever. I mean the funnel idea, whatever, powered funnel, flying V, whatever we want to call it, works potentially. Like we've never actually tried it with that many balls. But it could work. I don't know if there's another. And you could add like a powered floor to it if you wanted to, because you probably would need some way to like bring them all forward, right?
Yeah, I think
Conveyor, like a conveyor belt on the floor. Because we had discussed doing that with ours, but then realized we didn't need it on the 2021. Okay, so that's not bad. So the crazy thing that we've currently, in like this current plan, is that this thing gets really complicated, right? Like there's this weird intake thing that has to drop out a bunch of rollers, a place for big balls, a ramp for the small balls, and then somehow also store back up in the robot.
Doesn't need a ramp for the small balls because
It just has to fill the one middle gap where the balls come out. Like the bumper acts as the rest of it. Or it could, but you could the ramp helps too, because the small balls don't really like going up the bumpers. That's information back from 2017. Because I think at some point, like other people remember me mentioning the 971 making like crazy bumper numbers because of that. Yeah, the thing that got made illegal later on, like the next
got
season.
made illegal.
It's just the way they do their bumpers. It's super into details. Like you don't even know the bumper rules yet, so it would take, you'd have to know all the bumper rules to know what this was. But the rule got changed the next year to not allow them to do it. Okay, so that gets really odd because that's like one, basically almost becomes one mechanism having to do all of that, right?
Yeah.
Well, maybe it doesn't have to. I guess there's no reason they have to be tied together, right? The big ball thing could be its own thing, separate from the small ball thing.
Why?
That is a good question. Why is a very good question. Why is one of the questions we should always be asking.
Like, why not just have one thing?
Why is a good question.
But, how do we store this chuggiest thing above?
I think that's part of my issue is I think like the big ball wants to like rotate differently because the small ball is way easier to bring in and out because it's like closer and smaller. And the big ball, I would almost want it to like pick up and rotate like a much larger thing, but maybe not.
Well, we could do like what we did the past 2 years with the pneumatics. Just like flip up and down.
Right, yeah, you would do that still, but I don't know if going on a 90 and pivoting kind of near the top of the bumpers works the same way, right? Where for small balls, it almost certainly does. You can like pop down something or push something out even, right? You can just do a normal extension. Ooh, that's the other thing we have not really discussed is like expanding the small ball storage. Which I think we briefly saw in a couple of those videos, but we didn't comment on. So which one? So like
Oh, you
254
mean, like, over
does.
bumpers?
Yeah, so like that's part of the way they do their intake is the whole. Okay, YouTube. There we go. So yeah, so all of that, like that space in front of their robot. One second. Okay, yeah, all of this is extra ball storage.
Hmm.
And they have the side
It's a
Lexan
lot of storage.
is yeah, but so the way this game works, you can't hold balls above 18 inches, so it would be a little bit less because that's 24 at the top of that. But they also the side Lexan fans out, so the top of the side Lexan is like at the bumper edge for them. Because the way this game worked, the sizing restrictions were there was a certain size box you could ever be in, and that's as big as you could ever get. So like they started slightly small to be able to push their intake out in front of their bumper, basically. And then the wings came out over their bumper too. But like basically met, like, so if you put it against the wall, their bumper would hit first and their wing would be really close to the wall. So that helps a little bit. There's also, we could do stuff on the other end of the robot because we haven't done anything over there.
Oh, yeah.
Oh wait, actually, hold on. Do you have 2 small ball intakes?
Oh my god. You do have a whole other side.
What, like, how hard is that, right? Because you don't have this giant shooter tower here, right?
Yeah, it makes sense. Oh, we also haven't talked about where Climber's gonna go, but I guess that's kind of a simpler thing.
Yeah, Climber we assume Climber will fit around everything, right?
Yeah.
We'll make it.
Or is there still only a small ball intake on the back side? No, that gets really weird because otherwise your front gets jammed with small balls and there's nothing you can do about it.
Yeah, it'd be weird. Spinning things.
Or if like you'd have to like kick them away or something. Yeah, that'd get really weird. Huh. Is there a second small ball intake?
I don't see why not. We could just build a second one.
If it's Swerve, are there a
Twice the
third
balls.
and fourth small ball intake?
No, okay, calm down. This is too far.
That would be useless though. You'd confuse the driving.
Oh no.
Swerve, for people who, if you don't know, allows your robot to drive sideways, which would be right, you'd have one on all 4 sides. And there's complications to it. It's getting a lot better now though. There are teams who do it much better now. Yeah, I feel like 4 is too many, clearly.
4 is definitely too many. I think 2 is not terrible. Like, that seems fun.
Has anyone done something like that?
I mean, in different games, right? I don't think there was any.
Yeah, like in 17, did anyone?
Ooh, in 17, yeah, I'm trying to think who. Probably. I'm just trying to think who did it. Like almost certainly someone did. Like there were too many balls on the floor for someone not to think of that, right? Because like even in 20 people did, right? The because Engine Nerds did in this year, right? Yeah, so they have one on each side of their swerve drive. Someone almost certainly did in 17. I just cannot think of who. Who would have had double ball intakes? It wasn't Strike Force. They had a ball and gear like double intake thing. That worked pretty well.
Just wondering, could you do quadruple ball intake?
That's what I said earlier when I said 3 or 4.
I did not hear
Oh,
that.
it's all right. Yeah, it was the joke. Everyone was laughing. But it's possible. That was kind of the discussion was, if your robot can move in all directions, would you want to have intakes on all 4 sides? Unlikely. It's a lot of weight. It's more motors, more complexity. And how
Yeah,
often are you driving in all the directions? Right, that doesn't make sense. Like, there's no advantage to necessarily driving in one direction or another. The advantage of having the one on the back is that you could potentially only get small balls, because like if you already have 2 big balls, you could use that one whenever you're only collecting smalls and not have to rotate. Oh, it would also let you get fed small balls.
Oh, yes. No.
And it could expand your small ball storage, right? Because that one could fully expand out.
Mhm.
That's interesting. I had not thought of this at all. But if you did go to 4, you could expand your small ball storage even more.
Stop.
You could have a lot of expanded small ball storage if you had 4. You could have so much small ball storage.
No.
Yeah, why don't we just put 8? Oh no. Like you would have 2 on each side. 2 on each. That would
Yeah,
just
that's
be
probably
useless.
that's probably
8.
not an advantage over once you're spinning a roller on that side. Doesn't make sense to have multiple. We get a lot of expanded storage though. Like, what does your cycle do if you can just like
Or you had an octagon robot.
clean the floor, right?
I wonder if like
'Cause-
a Roomba type design would help.
because that's kind of what you were looking at earlier, Felipe, right? With how many balls to put in. Because if this gets higher, that number gets huge. Like no matter what you do, that number you can change these around to whatever we want. Not 12, that'd be a weird thing to deal with.
And now is chasing all those balls down worth the time?
That
As
is
well
a
as since
good.
we're single stream, so it'll take even longer.
This is true. But like you have to do it anyway. So do you take less cycles, but you just have a lot more balls? So then when you're aimed, you're ready to go.
Hmm.
Interesting. You also have to make sure you don't store above 18. So like this whole thing has to have some sort of top, which is tricky as well. Needs a top. Okay, other. What else do we need to think about for small balls before we? I think it's a pretty decent concept. Potential second intake somewhere. Ooh, what is keyboard's like double typing letters now? That's weird. It's the opposite of lagging.
Where can I access this slide?
I can throw it in chat. Nope. That didn't copy. Okay. That's better. I don't know what the other thing I wrote was.
Inside are different.
Yeah, that's. I guess that is a question. Potential back intake for more storage.
What more will this meeting consist of?
Question. A lot more of what's happening. There's not anything like new necessarily. We just have to talk about other subsystems from what we're designing. Okay. Thinking of the. Yeah, 'cause it's already 5:30. Okay, so there's a reasonable path to being able to start investigating small balls. Are there other design options that we haven't thought about that make sense to discuss right now?
I have no idea.
That wasn't,
I'm-
yeah, that wasn't directed at you, Luke. That was for everybody.
I know, but
Okay.
I
I
don't
have
know,
an
maybe
idea
I'll
for
put,
the.
maybe
I
I'll
have
put
to go
something
soon,
on the
so.
slide if I find some interesting article somewhere.
Sure, that's what it's for. What did you have, Grisha?
Yeah, I said I had an idea for the climber because I have to go soon. So
Sure,
I don't
yeah.
want to like take it.
Yeah, feel free.
So my idea is we have a retractable climber with a hook at the end, kind of similar to the one from last year, like the end of it, and you have it positioned at a certain angle above the robot. So we know that like if the robot goes up the ramp to like this extent, we know that it's going to hook over and it's going to climb to the high bar.
Yeah, so you'd have it already deployed and then you just drive up the ramp and grab the bar, is that what you're saying?
Yeah, and then you retract it back into your robot to climb.
Right, yep. Yeah, that seems reasonable. I'm not really sure what to, trying to think what to write for that. Something like that, roughly normal words.
I mean, extension, is that kind of like yeah, extension, yeah, I guess.
Yeah, the normal, like just a straight out, nothing too crazy.
Yeah, sounds good.
Okay. Okay, so then the bigger problem, if we have some ideas of how small balls could work, I think that it's reasonable to make an intake that goes around where the shooter would be or the launcher would be from underneath. Whether we have a back one or not doesn't really affect things. It affects some things, but not a ton. The real question is, how does the big ball stuff work? Because right now it just like comes up and runs into a bunch of things, right? Like,
Yeah.
in the sketch at least. Oh, good. Putting the Spindexter is a good plan. Because the from what we've discussed so far, the most reasonable path is big ball gets put into. I really got to get a new keyboard. I don't know what's happening anymore. What did G? How is that even? What? This is very bad.
What keyboard are you using?
No, it's just the batteries are dying or the keyboard's dying. One of the two. It's just getting bad. It's just dying. It's been dying all week.
Well, what type of keyboard is it?
That's not important for this, Luke. Sorry.
Okay, just wondering
that's fine.
because I have because the
Luke,
keyboard that I'm using.
I'm just saying, like, we
laptop.
don't need to. I'm intentionally trying to not divert the conversation to be about keyboards. Like, we're doing robots.
I will not.
Just remember, it's recording, Luke. So.
I mean, that doesn't matter. Like, people will watch it or they won't. But it's even if we were doing the same thing during a real build session, I wouldn't want to be talking about keyboards if that's not the important part. Okay, so.
Everyone is frozen.
Just for you?
Yes.
Everyone else is talking.
Oh.
You can log out and log back in.
Okay, because I have audio, but your hand is sort of in front of your screen.
Interesting. Nope, everyone else can see me, I think. So
Yeah.
I can see everybody else.
I'll leave and join back.
Okay, for big balls, there's an S there. The question is.
Wait, never mind. It's back.
Yeah, so how do we store them? Which, I don't know if any of that's gonna type. Interesting.
So we only need to have 2.
Yes.
What does that sound?
That would be back to the on-screen keyboard.
Oh my god.
Okay, it's fine. We'll get through it. I'll eventually find my USB keyboard. It'll be fine. Oh, now Kathleen died?
I think so.
Okay, I think everyone else is fine. Like
Yeah, it's just
Risha's
her.
fan is a good like indicator if my Zoom is working. Kathleen is. Okay.
So
that is not good. Kathleen, nothing is working. No, you're. Oh, back.
Can you hear me?
Kind of.
No?
Well, now you sounded fast. That was weird. You were sounding slow for a long time, and then like the "Can you hear me?" was like super quick. That was very odd.
I heard everything. Like I never cut out. Like I couldn't hear it all. So I was like, oh, she's gone, and I'm like, no, I'm not.
Oh, you were very gone for everybody else. Yeah.
You guys ever have it when you're in class and then the teacher cuts out for like 30 seconds, and then when it cuts back in, you have no idea what the teacher's saying because like you missed the context of like the last 30 seconds.
Okay, big balls.
We don't need to sort or anything for these probably, right? Because we're not. Because since there's only 2, you're basically just stacking them.
Yeah, that's exactly what I was thinking.
That should be reasonable.
Yeah, you probably don't need to have any special storage. I mean, you just have maybe a 20 and
A
might be
big
20
box.
inches
All you
from.
need is a big box.
yeah, will this be similar to the EveryBot intake last year, but bigger?
Is there intake?
Well, no, because you still want them centered though, right?
Well, yeah, but we can fix that with like mechanism wheels, right?
So it means our
Like some
intake
sort
is
of,
going to be
like,
single
angle
file, right?
Interesting.
I kind of like an angle thing to like force them to the middle somehow.
Interesting. Yeah, because we do have to center well. Okay, yeah, needs to center. Because we want them to come out the same path, right? We want them to come out the middle, even if we want to be able to collect them on a wide path.
So if we don't need to sort them, that means the intake is going to be like single file, right?
Well, no, so well, so that's the question is actually, how wide do we need to intake? So we're not collecting a ton of balls. We're probably going after most of the time on the field because there's not a ton of the big balls anyway. There's only 18 total, right? Most of the time you're only grabbing one at a time.
Oh,
But
wait,
we were-
Auton is potentially the question, right?
Mhm.
narrower would be better, I think, because there would be less kind of space. There would be kind of less risk of the ball bouncing around everywhere. And it's since it's like single file, you could take it and it'll travel to the shooter very, very quickly because there's no need for sorting. So if it's narrower, there'll be, like I said, there'll be less like space for the ball to bounce around, and it'll travel a lot quicker into the shooter.
In the depends on what's happening. So yeah, if it's going somewhere to a shooter, yes. In this instance, the idea was that this same like front roller would be used to launch the balls back out as the launcher. So like they're coming up and then they get like kind of stored briefly, and then change direction, they go back down and out the same way they came in, except down the center. So that's part of the hard part, is got to make sure you can actually do it centered. But yeah, Auton is the question, because if you did only because there were multiple teams in 2016 who had intakes that were pretty narrow, because you were only going after one ball at a time.
Well, the question is, what are the advantages of having a wider, really, what's the advantages of having a wider intake if we're only going to be intaking like 1 or 2 balls,
But that's the question. So, but there's times in Auton where they're all spaced out on the step. If you can drive up to the speed bump or whatever, grab 2 and drive away immediately without having to cross the step or drive at it multiple times, that's the big advantage. That's why it was listed as Auton is the advantage. Because yeah, that was kind of the point in 2016, was you didn't have to do that. So, or that was one of the points in 2016. So there were a lot of teams who had an intake that was relatively narrow compared to other games. So 2056 was one of them. So this is the Einstein Field in
Count it down with me. 3,
in 2016.
2, 1.
2056 is
Finals match 3. All that's left to do is crown a champion here in First Stronghold 2016. All 6 machines moving. 3 blue bots up and over the red defenses. Shots up and in. 3 red machines over the blue defenses.
Yeah, so their intake
Shots
wasn't
up and in.
that wide compared to the ball.
A little bit of a lead, 50 to 40. Drivers now take control. This is it, baby. Finals match number 3.
It was a little bit wider than the ball. You definitely don't want a 10-inch wide intake.
A quick boulder up and in, matched by
a little bit wider
the
than the
beach
ball.
bots. Their teammate, 2481, also makes it 3 for 3.
But it doesn't necessarily have to
15
be
points for red.
Huge.
1690. I think that boulder just flew out. They'll pick it back up. Good score out of 2056 now. A good score out of 1690. 330 and 120, dealing with some defense out of 1405. The Finney Falcons down in the blue courtyard, but able to get 2 boulders up and in. 2056, 1690, doing what they do. 2 more boulders for blue.
Okay, so then what does that tell us for what we're trying to do? So we're trying to figure out what the Auton spacing is, right? And we'd have to figure out what the Auton spacing is, which I don't think we have written down yet anywhere, because that was one of the things that never got put in CAD yet. The manual, I believe, calls for them to be equal distanced, right?
Yes.
So there are 12 balls. So that means there are 4 balls in this much space. 107. Is that length real? Yeah, the length should be real. Okay. The distance should be real. 107.5 inches.
What prevents you from?
It's like 35.
What prevents you in Auton from lining up and so all the balls line into a line in front of you and just pick it up one by one?
You have to get on top of the speed bump to do that. They're all lined up on the speed bump.
And then we're coming at it.
And we have to start on the initiation line, right? So you'd have to pick one up and either back up and pick up the second one, which might be okay depending on how fast you want to be, or you could potentially drive straight at 2, grab them, come back and score them, spin around and score them. But.
And with a wider intake, do you think you could realistically get 2 at a time when you do this?
That is what we have to figure out, right? So we don't know how far apart the balls are, so we have to do that math. So 107.5 is the width of across which 4 balls have to be equally spaced. So we're going to make a new part, and we'll have CAD do the math for us. So we're going to make a quick sketch on a plane. I'm going to draw. So how many, if we have 4 balls on this segment, how many segments do we actually have, right? So we have a segment from the wall. So if this is the side wall of the field, we have a segment from the wall to the ball, then from ball to ball, from ball to ball, from ball to ball, and ball to the middle, to eventually another ball, but for us we'll call it half, right? Because it'd be the edge of that kind of section. that make sense?
Mm.
So what we know is that these three are all, no, those three. Okay, I was like, I thought there was an extra line that I drew. These three are all equal. These outer two are equal. What's happening here? Am I like not? Nope, 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 nope. Also no. What did I end up doing? Okay. Normal two, please. Thank you. What is happening down here?
Is that a tiny line?
I don't know. What's it drawing? Are there like relations that I don't understand? I'm very confused what that is. We're gonna ignore that, but it's getting bigger. What is that? This is super weird. Is it some part of the origin that is just like being awkward? What? Okay, new plan. You're no longer on the origin. Okay, it's good enough. Okay. I don't know what's happening with the origin. It's displaying really weird right now. Okay, we have our little space. The total space was 107.5. So we're gonna make this 107.5. And then the trickier part is that
You just divide by 4, right? And it'll be
you divide by 4. Yeah, is that all you have to? Yeah, that should be all you have to do, right?
yeah.
Because you have half of it on the other side. That makes sense.
Yeah.
Seems easy enough because we're not doing anything different to the side walls. Because that's why I was thinking of. Because at one point we are going to do some different spacing and we ended up not doing a different spacing. Okay, so yeah, so you're like 26 something, and then this should be half that, hopefully. Yeah, okay. Yeah, so anytime this error comes up for people who don't use SolidWorks a lot, it's fine. You just hit OK to make it driven, and then you just can't change that because it's already defined by other things. So then we're at 13.4. So yeah, so you'd have balls 26.8 apart. So that's a pretty substantial amount of room to try to intake a ball. So yeah, maybe you don't care. So you still want it wide, but you're probably not getting. You might be able to. If you have a 30-inch wide intake, you'd have the center of the ball. You'd have the center of both balls under your intake, which is all you really need. If you get your intake basically full width.
But you'd also have to be like lined up pretty perfectly.
Yeah, you'd have 4 inches or a little like 3 inches-ish of error, which is not a lot.
Yeah.
But you can come at it at an angle, which helps, which we figured out. That was one of the tricks that we looked at this year. So if you have the two balls, say there's the two balls here that are like 26 inches apart, right? Let's figure out what I'm trying to do. Okay, if you have two balls here that are 26 inches apart, is if you drive at them at an angle, you don't collect them at the same time, and their distance that compared to your robot that you see, like if you draw perpendicular lines to them and you get the distance between those, gets a lot smaller. Does that make sense? Let me. Yeah, we can do it with the line if I can get the line back. Okay, so if we have, let's see, if we have a 10-inch ball and another 10-inch ball, what am I trying to do? I want to draw a rectangle that I can move around. Let's draw a 3-point rectangle. So if I go, nope, not give me Okay, if we go like this and like this. Okay, so if we assume this is coincident with that, this one's coincident with that. This thing is fixed, so it won't move when I move other stuff. As I move this corner, right, so if we come straight on, we're 26.8. As we angle more towards the ball, right, they get closer to a straight line the more you go, right? Does that make sense?
Mm-hmm.
So if you were able to come completely all the way straight, you'd be perfectly a straight line. But your intake, depending on how wide your intake is, it only has to get so wide. So like that's 19. If I tell it to be, driven, nope. What are you doing? SolidWorks took my menu away.
Maybe you could have an extendable intake, like maybe forks on the end that have rollers that kind of like push, like it's like an outer arms that have like rollers on them that maybe like push the balls toward the intake.
Right, so something closer to a 20-inch intake would be able to grab those two balls without having to be 30 or whatever it is when you're out straight, right?
Yeah.
This one can actually be.
Oh wait, did you guys hear me? I don't.
Yeah, you said something about forks.
Yeah. So maybe if you want to kind of encompass more balls, you can have like extendable forks on either side of the intake with rollers on them, and that may like grab them in some way and try to push them back toward the intake.
Yeah,
so
it's just anytime you have rotation that's happening in a different direction than a roller, it's either another motor or some sort of mechanical linkage to get that kind of perpendicular rotation. I'm assuming that you're talking about perpendicular ones, but I'm not really sure.
Yeah, it was.
So that way it gets a little bit trickier to do, where there's multiple other examples of feeding balls back to the center and centering with intakes. One of the ones was mechanism wheels, or what are often now known as vectored intake wheels, can help with that because you can bring them in on the single roller, but they kind of get driven into the center already. So even if you have a wider intake, you can still bring the ball in to the center where you want it to be.
Gotcha.
Yeah, so it doesn't seem too crazy. And we could just, and honestly, we probably could even do vectored intake wheels, which would get us back to quite a bit wider. So even if it was like this path and you have 25 inches, you could probably still grab them both. But there almost certainly is an advantage to being able to do that, because then you could grab them, spin around, fire two, do the same thing at the next two balls next to it if you wanted to, right? You could have a Aton that does way more than the single ball you start with. Oh, and the other thing is the intake roller doesn't have to necessarily even be the same as the, what am I thinking of? Because you could put like a separate kind of vectored intake roller out in front of the one that we actually shoot with that could like fold up and down on its own possibly. So it could be like out of the way when you actually go to fire. But that's a lot of moving parts again as well. But maybe.
Could we just shoot with the mechanism wheels if we do mechanism?
So you don't have to have mechanism in the center, right? Because that's the part going straight up anyway. So you'd only have mechanism to the outside anyway, right?
Yeah.
So that's probably fine. I don't think there's a problem with that. Okay, so that's not how that works. Yeah, that's not how this sheet works for that.
Okay.
But I mean, I guess you could, but maybe you could. It's not a big deal. Like it doesn't matter. But it's probably not for intakes. Okay, so what am I trying to figure out? The part of the process is just trying to figure out what part of the design process do we want to do, because a lot of it, because we don't have prototyping, we're just like making choices that seem reasonable, right? Like there's no, so much of this would be like, oh yeah, that's a good idea. Now build a prototype or build whatever it is to test and make sure it works. But we have to jump all of that stuff. So there's this awkward part of my brain that keeps saying like, well, we can't just jump to designing stuff and like choosing things. That's not how this process works, because it's not. But for this one, it kind of has to be.
Well, like you said before, it kind of has to be centered around the balls / intake shooter. So why not?
Yeah, like we're making reasonable decisions, but I also don't want to like I guess this part of the process isn't super important for what we're trying to do, right? Eventually, we just need to get people into and designing their subsystems. That's the more important bit of what we're trying to actually learn, right?
Maybe take a cautious approach toward what we're saying with the intake and shooter, while keeping in mind, like, kind of taking everything into consideration first, but then going back and then focusing on the everything that relates to the balls.
Oh.
Yeah, well, that's kind of what we're doing right now, right?
Yeah, well, some of the other issues, just like how much do we care about reality versus the virtual thing, right? Because we can also just CAD cool stuff, which is like fine as long as it's semi-reasonable, right? Because we're not stuck with our decisions in the same way that we have to like compete with this robot over a whole season in real life when we do it. So there's so much less incentive to not do semi-silly things. Like we don't want to do anything too crazy. It needs to be semi-real, but
all the stuff that you said back in the recording, I think if you go watch it, you said you kind of dismissed some ideas because it'll be too many moving parts. Then that could get like reintroduced because it's not really real. It's kind of
so like there's a difference of like,
yeah.
So too many moving parts are like, oh no, that's just not the right, like getting the right solution. Or what am I trying to say? There's almost always multiple right solutions, right? But some solutions in general are things that we would never build because they're too complex, no matter if they were not valid. Like they're just almost never the actual like elegant, correct solution. Where whether or not we have like a back intake is a different decision. Like there's like reasonable arguments to do it. It's not an overcomplicated mechanism. It's whether or not like it provides value to the robot or not, and that would be different in a real scenario than in this one, right? Because we don't want to design things that we wouldn't ever build. Like that's not real. It's whether the value of how much it's worth and things gets a little bit different in this argument.
Yeah, I'm just saying I feel like the boundary can slightly be pushed more than what we would use, like what we would build in a competition for real life.
The battery?
Boundary. No, I agree with you. And I think as much as I could, I was trying to make sure like that boundary made sense. So like when you were talking about like the fork intake and things like those, you wouldn't have like multiple motors on there no matter what. Like that's just not the way. Like that's just not. We've done enough intakes in the world to know like that's not the normal option. Like there's other ways to do that same kind of thing. There's a thing called the CD7 that brings balls in. We probably don't need it for this if we're only doing, because you're only doing 2 balls. It's less crazy. But no, I do agree. There are times where we could do things that are a little bit more out there, and we're fine with that because we don't actually have to build it. But it still needs to be sound design because that's the whole point of this exercise. So, like, we're still going to nitpick on things that aren't right in CAD.
All right. Well, I have to go. So see you guys. Good luck with the rest of your meeting.
Bye, Grisha. What is my next question? I think this is a reasonable robot design. It's definitely not what I expected the robot to look like, like from designing the game the entire time. But I think it's better. It's not terrible. Like that works. You have to somehow big ball tube, but the big ball tube is a relatively easy thing, right? It's either a conveyor or a couple wheels. Like it's probably just a wheel actually. So that's what are we? What craziness can we do? So things we have not talked about. What does motor allocation look like? Why is my? Oh no. So there are what motors are on this robot? Somebody want to start typing?
Oh.
My keyboard's messed up, so if somebody types it'd be easier.
So, how many, or how do, I don't even know how motor allocation works.
So like right now, don't worry about like type. Ignore type. That's whatever. Right now we're just talking about like, okay, we need one motor to intake the small balls, right? We're very confident there needs to be a small ball intake motor, right? So it's literally just listing out where we think they're going to be actuations. So it's like one for that. There's
For big ball?
at least one for big ball, right?
Mhm.
Which may be intake and shooter. Is there a second for big ball to like not, assuming we're going to launch with the same, or somehow there's a launcher that probably means that the ball can't be touching the launcher when it's spinning up to speed, right? So kind of like our tower, there has to be like a thing right behind it to like feed the ball in.
That makes sense.
So there's probably another one there. So there's probably two for big ball. What else? Yeah, drivetrain gets some amount that we don't, at minimum 4, but I don't know if there's more than that is a different thing.
Just leave it blank for now. Come back to that.
What else does the robot do? Climb. So minimum 1.
Yeah, I was gonna
maybe
say
more.
As well.
Because we know we can do it with 1. But this last year's robot had 2 technically, but it probably could have been done with 1. Yeah, small ball launcher, right? That's the one we don't have right now. Minimum 1. And then what's the other thing?
Oh, spin mixer.
Yeah, there we go. That's one for almost certainly only one, I would think. Can't imagine building a spindexer that needs more than that. So where are we at? We're at total 1, 3, summa number 3, 4, 5. So 6. Put climber at 1 because climber's probably only 1 nowadays. If you need more than a falcon, I don't know what we're only picking ourselves up, right? Like it should be fine. So that's 6. So if we ended up with, what are the things we could also end up with? So you could end up with like a back intake, which would be a 7th. And then you have 4 in the drivetrain, which is 11 if it's a normal drivetrain. 8 in the drivetrain if it's swerve, which is 15.
No. That's a lot.
So I mean, it could be swerve.
Yeah.
Like we have the motor allocation for it, even with a back intake. Are there any disadvantages to being swerve in this game? You have to make sure you can cross the speed bump in every direction. Right?
Yes.
Doesn't seem too hard.
Yeah, it doesn't seem too bad. You may need to have little like idler things so you can't get like perfectly beached in the center somehow, where like none of the four wheels are on the ground. But as long as you have something that lets you like tip to one side or the other, you're probably fine. I guess I don't know who's still on the call. I haven't actually even looked at participants in a while.
I'm still on the call.
I know people have left.
I just haven't said
Oh, a
much.
lot of people.
No,
are
you're
like,
cool, Sebastian. That's totally fine. Okay, yeah, Mason and Grisha, who have signed up to be people, aren't here. Those are the two that
Mason left. I
right.
think
Yeah.
hour ago.
Yeah. Okay, that's super weird.
I feel like this meeting's been longer than the other ones.
They are longer because this is actual work. Like this is what we do.
Oh,
So like
this is actual work.
yes, like this is the project that the veterans are working on. This is why we said like
Okay, that makes a lot more
yeah,
sense.
like they're about to like we're basically planning stuff out, and then like different people are gonna take sections and they're gonna start like CADing through the entire parts of the robot.
Okay, because
Oh wait, weren't we gonna have our lottery today?
Well, we were trying to figure out what was going on, and then we were right. So then
Yeah,
I think
yeah.
we'll do lottery maybe Tuesday. I don't know. We'll figure it, or like we could do it whenever.
Yeah.
But I think we need to figure out who wants to do what.
Today. I didn't realize because other people have left.
That is true. So I do think that's part of the question is just somebody because Swerve CADing the Swerve is a lot easier than CADing a normal drivetrain. So I don't know if people want to CAD with the old drivetrain or do we just CAD the Swerve and be done with it? Because CADing Swerve takes like no time. Because CADing Swerve is here's 4 West Coast modules and some tube, and our drivetrain's done. There's some intricacies, like there's some stuff, especially with the ball gap, and like how to mount the Spindexer and everything, right? But it's a lot simpler than doing all the chain math and potentially doing like the crazy thing we did over the summer where we had like flanged holes and things.
Oh, what were those called again? I
The
forgot.
punch and died, whatever. I don't know what the.
Yeah, that. No.
Yeah. Because that is one nice thing about potential Swerve is that you can design a drivetrain in like 4 minutes. Like it's like here's 4 modules, here's extrusion, you're done. It would be a somewhat interesting challenge so that programmers should have something to do because they could potentially learn to program Swerve, but only somewhat.
Because we can't actually like test it.
Yeah, but they can run the simulator and get something close. Interesting. What are the other subsystems at this point? So we have drivetrain, Spindexer, climber, crazy ball intake shooter thing.
Yes.
Oh wait, no, I missed one. Wait, what did I say? Spindexer, drivetrain, climber, crazy ball intake shooter thing, small ball shooter thing.
Yes.
Which could be potentially combined with Spindexer, maybe.
The shooter?
Yeah, because those are like the connected things, right?
Oh yeah.
How do people want to? I guess how do people want to divide up work? I think that's the other question we have.
Like
Like
what do you-
'cause we're dividing up subsystems, right? Like we normally would, but also like.
The whole intake shooter situation is weird.
Yeah. So one, we have the whole intake shooter situation. Does anyone want to design a drivetrain? Because we like don't have to, right? We could just say we're doing Swerve and like I can give you guys a drivetrain in by like 30 minutes, or any of you can. It's the easiest thing. Like it's legit. Like we just like I don't think 148 released CAD yet, but any of that like
just down.
Just download a Swerve.
it's literally the Swerve module 4 times and 4 pieces of extrusion. It's so easy. Like the building of it is not the hard part. It's definitely the programming of it that's hard. And the fact that it takes up all your power in your breaker spots. But that goes away in 2022, which is the nice thing.
I probably wouldn't want to, just if it's that easy, you know. Like,
Well, that's what I'm saying. So like, no, but I'm saying if no one wants to design a drivetrain, if someone really wanted to design our normal one, we could do our normal one, and somebody could go through the process of designing it, right? But it's not that crazy either, because it's just like plugging things into the spreadsheet and getting it right, and like it's not that different. If someone
How
has a cool
hard
idea
would-
for a different drivetrain, we could do that too.
How hard would it be to design a drivetrain?
Like our normal one.
Yeah,
There's a lot of details and things, but it's nothing
because
too
it
crazy.
looks,
We intentionally
'cause
do it fast, but like that's
Okay.
because we've almost every year that we do it, we know roughly what we're going to build. So we have the person who is going to CAD it learn how to do it in the fall. They kind of make all the mistakes then, and then we normally have it done ish with some tweaks because we always do it. But like it's normally like a week and a half after kickoff, and it's
it looks,
pretty much done. Like we get it.
because to me it just
fast.
looks like a glorified box with holes.
There are a lot of details.
Well, yeah, there's a lot of
Lots of
there's a lot
details.
of holes. Yeah.
But no, it's like how you construct it. Like there's a lot of different choices. Like we made some improvements this year that were
What I was
very
trying to
different.
say is it seemed like something simpler than the other things. No.
Not necessarily.
think
Like
so.
I mean, what Jack ended up doing this year was a lot. Like I mean, we designed a whole new gearbox.
his
Like
CAD looks like really complex.
yeah, like there was a lot going on in this past year's drivetrain. And if we start going into whatever, I don't even know what we called. What was the nickname for the summer or the fall summer thing I was working on? I don't even remember.
The star thing?
Yeah, there was like a video, right?
The Star Wars thing?
No.
Oh,
I don't remember what it was. There's a thing.
I guess that was just beginners overconfidence.
Yeah, I didn't
drivetrain
forget
look-
Star Wars. No, we had a drivetrain that I was working on because there were some new concepts that we were going to look at, which we still may do in the future. But
So
we
drivetrain
haven't
is
done
not the simplest part.
No, like the way we do drivetrains, no, not at all.
Oh.
Like, I don't
Intakes are
know.
normally pretty simple. Shooter takes a lot of dev work, but the actual CAD for it isn't horribly hard. Like real life
I was
work,
trying to
it's a lot of hard.
think-
So there's a lot
I
of
was trying to think of-
iterations.
I was trying to think of ways that I could help out.
So a lot of it
Right.
is just being able to like see what other people do. So like the way the team always works is like the subsystem manager are people who have been on the team before, and everybody else is like you're following along, asking questions. In real life, there's a lot of like actual work to do. Like there's a lot of assembly, testing, all that gets done. With this one, this is a lot more specifically to this challenge is for people who have been doing it more and have already done CAD and things. So we're not training CAD. Oh, Nova, that's what it was called. Now I remember.
With the dimple dies.
Yeah, dimple dies. Yeah, there we go. That's
What's a
what it
dimple
was.
die?
These like hole things that have flanges in them, but I couldn't CAD the flanges, so it was a whole thing.
So
Was this just me talking to you, Kathleen? I think it was for all of like the second part.
Oh no, that's the one that we stayed on for a long time and like.
Probably, because there were other people there for the first bit, but then
Yes, I think for a while it was.
there was not. I was like, I don't know, I'm just messing around, and then I just put it on YouTube anyway, because we're just learning how to do stuff. But yeah, like any of the Sebastian, yeah, any of these like design reviews that exist in our CAD library, those are cool to watch. They describe like our old robot a lot and like all of our old robots. Those are handy to learn a lot about like how a lot of what we do and a lot of the CAD parts of it. We never got anywhere on the Clawbot project. I'm also going to stop recording for this because this is